Good afternoon. Do you hear me? Is it okay with my voice? Okay, so let's start. Let's start now with your questions. This is again our advising hours on mathematical analysis 1 course. So you can give your questions, your problems, and we'll try to solve together this kind of examples. Okay, any questions from you? If you don't have any questions, I will switch on the demonstration and we'll solve some sample again as yesterday.
I have a question
okay.
About yesterday's sample, number 7 question.
And what was the number 7?
Integral.
Improper integral or?
Improper. I tried to solve, but I cannot.
Okay. Just a moment. Let me switch on this one. I said I will to consider it and send it by group. Yes. Unfortunately, I forgot this one.
Yes.
So, okay, I will do it now. Okay, I will do it after this session. Okay, I will send you. I need to check first of all the example, and then I will send it to the group. Okay, will it be okay?
Yes.
Okay, thanks. Now let's another new questions. I mean, this is the previous. This is the yesterday's question, which you said new ones. Let's do it. So here we have Eldar now. Welcome, Eldar. So your questions. Do you have some samples?
Good morning. Actually, I have no, but I just joined to revise something.
Okay. Principal part. Can you explain it? Okay, I have explained it yesterday also. Principal part. How to find a principal part. Okay, let me one more time show you how to find it. There are two functions, f and the test function, any g of x, or we have denoted by phi of x. So let me write here. If you remember, we need to find here a principal part with respect to any test function g of x, yes? To find it, we need to find here limit as, just a moment, I need to switch. Limit as x tends to any c f of x over this g power of alpha of x. So in this case, it should be finite. It has finite limit L. And this is, so this finite limit L, and using this finite limit L, we will find principal part. And the formula of principal part, P of x is equals to now L times G of alpha x. And the g fx and gx is given any two functions. And here should be find with respect to g of x, Is it clear? For example, let me demonstrate. Just a moment. Let me demonstrate it. So, for example, here we have one example, exercise number 4, principal part, find the principal part of this function. So to find it, what should we do here now? Again, using this formula. So limit as x tends to here, where it tends x now? X tends to 0, and f of x is given. So f of x divided by g power of alpha x. Here g of x is test function. It is equals to x, and you need to find here limit. It should be finite limit, and your alpha it depends on your. So this f of x, of course, should be in same powers in this case, yes, because of here should be finite limit as x tends to 0. So for example, in this case, what should we do? Cosine and limit as x tends to 0. So here we have x power of alpha. Of course, we need to define alpha also. And cosines, this one, these functions, cosine 3 square root of 2x plus logarithm. So I think we need to move it. Logarithm, so logarithm 1, I think it's clear, 1 plus 9x squared minus 1. Yeah. So, and then as x tends to 0, where it tends? Cosine 0. What is it? Cosine 0. It is 1. Yeah. And here also we have what we have. Logarithm 1 plus 9x squared. It gives us logarithm 1. It will be 0 again. So, and then minus 1. So as you can see here, we have 0 over 0. Yeah. But what should we do in this case? What kind of changing in our functions we can do it here? Students? Any idea here? Yeah, we can use L'Hopital's rule, but here we need to define alpha here, x power of alpha. It should be finite limit. That we don't need here find the just limit. We need to define alpha also. Do you understand me? Here we have two parameters as we can see.
It's just the power of x.
Power of 1, or you mean which power?
I mean, after all that, we have only like cosines. If you put 0 on the cosines, it will be just 1, and it will have just logarithm 1 plus 9x in square.
Mm-hmm.
And it is, if I'm not mistaken, it's similar to 1 plus 9x squared. Yeah.
Yeah, logarithm 1 plus x. No, logarithm 1 plus x. What was the formula? Logarithm 1 plus x. Taylor's polynomial. We can use here Taylor's polynomial.
Yeah.
Logarithm 1 plus 6. What was the logarithm 1 plus 6?
I remember that it was something really easy one, the easiest one, but I don't remember exactly what it was.
So we can use here, yeah, we can use here also.
20?
With using derivatives, we can do it.
We can just.
So do you remember it will be now F0. What is F0 here? In this case, F0, it is log 1. It is 0 just, yes? So 0 plus x minus x squared over 2 factorial plus x cubed over 3 factorial, and so on. Did you remember the formula? So that's why here we can use this kind of formula here. And also we can use, in this case, equivalency of the cosine x as x tends to 0. What we have here,
we're using the Maclaurin formula. Cosine x equal to 1 minus
equivalency of cosine x.
1 over 2 x squared.
1 over 2
x squared.
Yeah. So x squared over 2, yes? But it should be 1 minus cosine x. It should, look here, 1 minus cosine x. It is equivalent to x squared over 2, like this. Is it clear? You understand me?
Yeah.
So that's why here we can change our previous expression to, look, 1 minus cosine x. Can you write here 1 minus cosine x, like just doing like this, minus 1 minus cosine 3 square root of 2x. Can you write it by this way? Is it clear for you? Now, yeah. And now here we can continue. So, and here we have plus logarithm 1 plus 9, what was 9x squared. So, and now this is equivalent with x logarithm. So here we have 9x squared. And here we have, what we have? Yes, that's why, yes, correct, Abdullah. That's why we can use here equivalency like by this way. 1 minus cosine x equivalent with x squared over 2. First term here. Yeah. So this is same is your notation. And now here we have minus x squared over 2. X here is this one now. 3 multiplied by 2 squared, it will be 18 x squared. Yeah. Do you understand me? Divide by 9. 2, sorry. And here, next one here. X squared over 2. We will just take these two ones here as logarithm. So in this case, we have 18x squared over 2 plus 9x squared minus this one, minus this one. So 9x squared, it will be, look, it will be minus. Here I will write. Let me clear this part. So instead of logarithm, we'll write now 9x squared minus, here we have 81 x 4 divided by 2, like this. Am I right? Do you understand what we get here? Guys?
Yeah.
So here now we have what we have. This one gives us, this gives us now minus 9x squared plus 9x squared. They are canceled. You can see, yes? So, and here we have only this one, minus 81x squared. Is it not visible? Is it visible now? Students?
It's visible actually.
Okay. Maybe some, this with some pause, maybe. So now here what we have, minus 9x squared plus 9x squared minus 81x squared over 2 factorial. And the result here, so what is alpha here? What is alpha in this case? Alpha is 4, correct? Amir, alpha is 4. And the L here is, I think here is some mistake in these coefficients. I think. Should be, by this version, it should be this D1. Maybe here we have some mistake with coefficients when we find, when we expand the functions. 1 plus 9x squared logarithm, it is 1 plus, so x minus x squared over 2 factorial, x cubed over 3 factorial, x squared over 2, it should be 18. So 3 squared of 2, 3 squared of 2, it will be 9 times 2, 18 over 2. All of them is correct. Maybe here some mistake we have in version, I don't know. So we need to check it one more time. But this one is correct. So here alpha is 4 and the L here is minus 81 over 2. Is it clear? Any questions here?
Yes, can we solve this one without Taylor expansion?
Without Taylor expansion?
Yeah.
In this case, no. Because we need to expand the function. Of course, we are using sequences of the fundamental limits. This is the sequence of the fundamental limits. Of course, we are using Taylor expansion, but they give also sequences of the fundamental limit. This, for example, 1 minus x equivalency with x squared over 2. Yeah. How can we get it? As x tends to 0, also we can. As x tends to 0, only we can get it. Natural logarithm. So in natural logarithm, what we have, okay, log 1 plus x. So what kind of idea you have? It is Amir. Yes, Amir. We can change also, of course, logarithm 1 plus x. Logarithm 1 plus x, you can change with x also, or with e powers, yes, with e powers also. But I think it will be same. It will be same. So you can see here what we have. Here we have 9x squared. Because of logarithm 1 plus x, look, Amir, 1 plus x, it's equivalent with x. If we consider here just x, so what we have here, we have only 9x squared. Yes, logarithm 1 plus x, it's equivalent with 9x squared, but it is not gives us correct result because of here again we get 0 over 0. Do you understand me? That's why we need to open it in more terms using Taylor's polynomial. Is it clear for students why we are using here Taylor's polynomial in this case? Because they gives us now minus 9x squared plus 9x squared, which is equals to 0 again. If we don't use Taylor's polynomial here. Okay. Any other questions? What kind of questions? Okay, yeah. Now, which topics are not clear for you, let's say? I can clear. So now, for example, if you continue this one, third one is derivative. Second, okay, let's start first one. Consider the following improper integral. Decide which one of the following is correct. Again, improper integral we have. So how to define here converges or diverges in this case?
As a power, it's
yes, we are using here.
-1.
Yeah, we are using here comparison theorem. Am I right, Elder? Comparison theorems. So if the biggest one converges, smallest one also converges. If smallest one diverges, the biggest one also diverges. Here we need to find a new function. Compare this function, x squared plus 4x plus 10. So we can compare it like x squared plus 4x, for example. Yes? Just subtract 10 here. If you divide by x, it will be now, since x greater than 0, you can see x greater than 0, we can do it. So it will be 1 divided by x plus 4, or again, if you continue, it will be 1 over x. So using harmonic integrals, improper integrals, 1 over x, integral of 1 over x from 0 to plus infinity, it is so now we need to do it conversely. So look, we need to show here it is greater than 1 over x, like this. Look, not this one, sorry. So look, like this. This is diverges. Look, 1 over x should be like this, x squared plus 4x plus 10. How? Now, from divergence of this one follows that divergence of the given one. Do you understand me?
Yes.
And how to show here divergence of the, so how to show here comparison of the 1 over x with this one?
Just by like ratings, for example, starting from 10 and etc.
Yeah,
Like the extra elements.
Yes, we can prove it very easily. For example, here so we can prove it. How? Look, so here we have x on top and x squared denominator. So it will be, this will be greater than or equals to, look, here we can write, for example, x plus any x squared, for example. Yes, we can add here, for example. Will it be correct? Yes, because of x here, if it is any value, x squared will be positive 1, yes? And we can just find here correct one here. Okay, how we prove? X power of x, where? Is there a x power of x on the rightmost side? Or big, where do you mean? No, here, no. Here we can do, for example, this one, show that this one greater than some kind of function where it will be not converges, where it diverges. For example, we need to show this one will be greater than or equals to any other function. So, for example, here we can add x squared plus 4x plus 20, for example, let's say. Will it be greater than this one? I mean, this is left side greater than right side? Okay, say?
Yes, it is greater because
yes, of course, greater because of denominator. We are increasing denominator, but the number will be, the fraction will be smaller. Yeah. So by this way, we can just continue this process. And for example, here, now we can divide by x, and here say that it should be, for example, this one, this ratio will be greater than or equal. For example, I will write dividing by x, and I will write here instead of 4x, for example, 10x, I will do it. So by the same way, we can just prove that this will be greater than or equals to 1 over x plus something. For example, 100. Let me write. Doesn't matter here what we have. Yes? After dividing x here. So in this case, we can say that, but 1 over x plus 100, it will be diverges as x tends to plus infinity. It is harmonic integral again. So since it is diverges, the given one will be also diverges because this is greater than this one. Is it clear now? Look, I just write here 100. It doesn't matter. For example, here we'll put instead of 4x, 100x. Instead of 4x, just 100x. It doesn't matter because here x greater than 0, as I said. X not negative here, so it's positive. So we can add, and then you get here something else, which is less than given one. So our aim is here find another function, another integral which will be less than this one, because here it is diverges. It's visible. It's diverges. So and it's diverges to plus infinity. The correct answer here is this C1. Any questions here? After dividing x, it will be x plus 100 then. Numerator and denominator. So after some minutes, it's closed this session and you need to rejoin to this session, okay? Because it's free version. Now, second question. Consider the function. Decide which one of the following is true. Okay, it's given a function f of x. Check each of them. Each possible cases. 5 cases here. Have to check it now.
Take derivative and then take another derivative.
Yeah, derivatives, and then define here asymptotes. Also here you can see each of them we need to check here. Bounded below or bounded above. So take the derivative. We can start, for example, with derivative. F prime x is here. What is it now? So plus e to the power of 3, e to the power of minus 3x, and the minus 2 e to the power of 2x. Yeah. So, and here define, can just show solve the inequality. Yes. For example, equating y 0. Do we have here stationary points or critical points? Do we have? How to find stationary points? Yes, we have. How to find it? 3, or we don't have. 3 e to the power of minus 3x equals to 2 e to the power of 2x. Yes? When minus 2x, where is minus 2x? Yes, minus 2x. Yes, correct. Minus 2x. So when equating these ones, do we have here e to the power of minus 3x equals to 2 over 3? Do we have here stationary points, I mean? And what is it? If we don't have, why? Please be active, students. One more time, I will repeat. This is not lecture. This is not practice. This is advising hours. So you need to be active here. So are they equal? Do we have solution here? So here is some version from IBEC. Just let me check what is the versions. So, and Abdulaziz gives the version e to power of x power of -3/2. This is 2/3. Natural logarithm. Natural logarithm, is it true? Natural logarithm 2/3 is minus. E to power of -6, 2/3. Why? Shouldn't the derivative be? No, this one is correct. This one is correct. So yes, here we have one root. Here we have one root, which is equals to x equals to here minus natural logarithm 2/3. So here we have one stationary point. And so is it bounded, this function? Is it bounded? If it is bounded, bounded above or bounded below? Or why it is bounded above? Kamala? You can just consider e to power of -6. And what kind of function e to power of -6 here? Bounded above or bounded below? Yes, correct. So here, no, for example, here, I just show e to power of -6. Is it bounded above or bounded below? No, e to power of -6 here. What will be the graph of e to power of -6, Abdulaziz?